2.23, rationalising the denominator. Rationalising the denominator of a fractional surd, because it has to be fractional, otherwise it doesn't have a denominator, means writing that surd with a rational denominator, not a surd. So the denominator needs to be a whole number, okay? To rationalise the denominator of something like a, in this format, a over the square root of b, we multiply this surd by the square root of b over the square root of b, which is really multiplying it by 1, since the square root of b squared is b. Now, I'll show you. So if I've got a over root b, I multiply, so I go a over root b times root b over root b, and what's the numerator? A root b over, what's the denominator? What's root b times root b? It's b. So now, this resulting surd is rational. The denominator is rationalised. It's a rational number. So if we look at the denominator now, it's a rational number. Whereas before, when we started, the denominator was a surd. Okay? Now that's the easiest type of denominator to rationalise, but often the denominators are not in that form. Okay? So to rationalise the denominator of something like this, in this format, a plus root b over root c plus root d, we multiply by the conjugate surd. It's called the conjugate surd of the denominator. Right, so the conjugate surd, so to rationalise the denominator of this, multiply by the conjugate surd of the denominator. So the conjugate surd of root c plus root d is, actually we don't just multiply by the conjugate surd, it's the conjugate surd over itself of the denominator. One sec. The conjugate surd of root c plus root d is root c minus root d. But you multiply by, it's not just root c minus root d, it's root c minus root d over root c minus root d, so that you're multiplying by 1, all right? So writing that is not quite right. We're actually multiplying by root c minus root d over root c minus root d. Okay? So, for example, root a plus root b over root c plus root d, that's my original surd, fractional surd. To rationalise that, I just multiply this surd by root c minus root d over root c minus root d. Okay? Why do I do that? It's because the denominator, so the reason we do it, why? Because the denominator forms what? Root c plus root d times root c minus root d is what? Yeah, it forms a difference, this is why we do it, of 2 squares. Now when I do that difference of 2 squares, the reason we do it is the following. If I expand that denominator, you know, I've got a plus b, a minus b, isn't that a squared minus b squared? It'll be root c squared minus root d squared, which forms c minus d. So that is why we do it. Now we're going to do it over here, all right? So why? So if you're ever wondering, do I do the same sign or not, it's got to be the difference of 2 squares that by doing that you lose all surd components in the denominator. If you multiply by root c plus root d over root c plus root d, you'll end up with a perfect square on the denominator. You'll still have a surd term in the middle, all right? So if I was to now expand this, I've got root a times root c, then I've got minus root a times root d, plus root b times root c, minus root b times root d, but over, as I did before, root c squared minus root d squared. which is that numerator. Sorry, I don't really want to write it out so many times. So it's the actual original, that numerator over C minus D. So we can see that the, so this is the bit you need. And yes, we've worked out the rest of it under there, but you need to multiply by the conjugate surd over itself. Okay? All right. If you want to multiply by the conjugate surd over itself, got it? Of the denominator, that makes sense. Multiply by the conjugate surd over itself, of the denominator. All right, we'll do some examples. Exercise 2.23, some examples. Rationalise the denominators of the following. Okay, so all the questions are the same. So what do we do with the first one? We just multiply by times what? Times root 5 over root 5, which is, I'm just going to work across because I haven't left much room. So it's root 5, because there's more than one thing on the numerator here, it's root 5 times the first thing, root 5 times the second thing there. So what have I got? Root 5 times root 5 is root 25, which is 5, plus root 5 plus 2 root 2 is, what is it? Root 5 times root 5 is 5. Root 5 times 2 root 2 is, what? 2 root 10 over root 5 times root 5 is 5. Now, we look at it and we see whether we can simplify it or not, and we cannot. You cannot go 5 divided by 5 is 1, because it's 5 over 5 plus 2 root 10 over 5. Because there's a plus sign here, don't even think about cancelling. All right, next one. It would be different if this 2 out the front was a 5, because I could take out 5 as a common factor and divide by 5. All right, the next one. 4 root 3 minus 2 root 2 over 7 root 5. What do I multiply by? Yeah, you don't need to multiply by 7 root 5 over 7 root 5 because the 7's just cancel. So it is by root 5 over root 5, not 7 root 5 over 7 root 5, okay? So again, more than one thing on the numerator here. Root 5 times 4 root 3 is 4 what? Root 15 minus, I think it's 2 root 10 again, over what? Over 7 times 5, which is 35. Now have a look at 4, 2 and 35. There's no common factor between 4, 2 and 35. If I had 4, 2 and an even number down the bottom, I would have been able to simplify, but I can't. All right, the next one, question 2C. What do we multiply by? The conjugate surd of the denominator, which is root 5 what? Minus 2 root 6 over root 5 minus 2 root 6. Now that equals, I'm going to put brackets around anything that is not a single surd. 2 root 3 times root 5 is 2 root 15 minus, now we're going to have to do some simplifying. 2 times 2 is 4. Root 3 times root 6 is root 18. So it's 4 root 18 over, all right, difference of 2 squares here now. So what do we get? 5 minus, be careful, square the 2 and you get 4. 4 times 6 is 24. Now we're going to have to do something with 4 root 18. Isn't that 4 times root 9 times root 2? So I've got 2 root 15 minus, this is 4 times root 9. What's root 9? 3. So 4 times 3, that's 12 root 2. If you want somewhere else, I just didn't leave enough room there. I know that root 18 is root 9 times root 2, all right? So it's 4 times 3 times root 2, which is minus 12 root 2 over 5 minus 24 is negative 19. Now, 2, 12 and 19 don't have a common factor. I can't simplify. Wait a minute. However, notice I've got 1, 2, 3 terms in this expression. If you do So what I'm going to do, the other way you could write this, instead of putting the negative on the denominator, I can actually, so I've got this divided by negative 19. That is the same as doing negative of the numerator over a positive denominator. So let me just write the 19 first. If I do negative of the numerator, I get minus 2 root 15 plus 12 root 2. So I'm going to write it as 12 root 2 minus 2 root 15. Now, how do you know when to do this? See how I've got 1, 2, 3 terms and 2 of them are negative? If you've got a surplus of negatives in a fraction, that is when you do it. So I'm going to do positive, whatever this might be, divide by a negative. I'm bringing the minus up the top and I get minus that plus this. It's best to write the positive term first. Are we okay with that? Or you know what it's the same as doing? Multiplying the numerator and the denominator by negative 1. Multiplying the numerator and the denominator both by negative 1. Okay, because this bottom answer here is a more simplified version than the top one. So just saying, if we looked in the answers for 2C, it may be written this way as opposed to that top line. All right, the next one, root 2 plus 5 ordinary 5 over root 3 minus root 2 times what? Root 3 what? Plus root 2 over root 3 plus root 2, which is brackets, brackets, all brackets. So what have I got? Root 2 times root 3, root 6, what's next? Plus 4 plus 5 root 3 plus 5 root 2 over, what have I got here? Root 3 squared minus root 2 squared. Root 3 squared is 3 minus root 2 squared is 2. Hey, there's no denominator. Any like terms? So that's over 1. I think it's just root 6 plus, it doesn't matter which order you put them in, plus 5 root 3 plus 5 root 2. I'm putting my constant term because the denominator is 1. All right, now the next one, be careful. If you were to, before you start this, instead of rationalizing both, look at the two denominators. What are they? They're already conjugate surds of each other. So instead of multiplying, so really if you just make a common denominator, you will have rationalized it. Do you see? Because the two denominators are conjugate surds of each other, you don't need to multiply. So it is actually doing the same thing anyway. I'm just going to make a common denominator here, which is 2 minus root 2 minus root 3, root 2 plus root 3. And what do I do to the first term? I multiply it by root 2 plus root 3, put a minus sign. And this second one gets multiplied by root 2 minus root 3. So what I'm really doing is multiplying the first fraction by root 2 plus root 3 over root 2 plus root 3, multiplying the second fraction by root 2 minus 3 over root 2 minus 3. The only thing that I saved on writing was writing the denominator twice. So when the denominators are conjugate surds of each other, just make a common denominator. Yes.
In 2e, shouldn't it all be a 2?
1 sec. Yes, it is. So up here there is an error. Root 2 plus root 2 is 2. Thank you. 2. That's a 2. Okay, let's keep going. Thank you. So what have we got? The denominator here is, be careful, it's 2 minus 3. A minus b, a plus b is a squared minus b squared, which is 2 minus 3. It's going to be negative 1, right? So what's our numerator? Root 2 times root 2 is 2 plus root 6. What have I got? Minus 3 root 2. Be careful. Negative times the negative is plus 3 root 3. Now, the denominator is what? Negative 1. So now I need to divide. I don't leave it as negative 1. I divide the whole numerator by negative 1. Okay? So my denominator is negative 1. I'm just going, equals whatever over negative 1. Because I've still got the same numerator and negative 1 denominator, you would never write it over negative 1. Even though I'm going to have more negatives now than I do, a whole number is still simpler than a fraction. So what have I got? Negative 2 minus root 6 plus 3 root 2 minus 3 root 3. Okay? So that is the simplified form of that. Now be careful. Are you going to rationalize here, or this is... You could just multiply first if you want and then rationalize. You can do it two ways. You could either rationalize each one and then multiply. This is multiply, not add. It's multiply. Why don't we just multiply the two fractional thirds and see what we get? All right? So we're going to this is multiply, not add or subtract. So I'm not going to rationalize each one first. I don't know. I'll just multiply. Let's see what happens. All right? Let's multiply. Because then we only need to rationalize once. But, I don't know. It could be easier the other way. I'm not sure. Let's go. Root 2 times root 2 is 2 minus root 14 over, what have we got? Root 2 times 2 root 3. 2 root 6. Root 2 times root 2 plus 2. Root 3 times 2 root 3 is plus 6 because it's 2 times 3. And root 3 times root 2 is root 6. Don't go rationalizing yet. It can be simplified. 2 minus root 14 over what? What have we got? 2 root 6, 3 root 6 plus 8. Now that you've got that on the same line, you can rationalize. Times 3 root 6 what? Minus 8 over 3 root 6 minus 8. Everything in brackets that is more than one term. And let's multiply. 2 times 3 root 6. So you do it and I'll do it here. 6 root 6 minus 16 minus 3 root 104, so 84, 84. So it's 60 and 24, 84 plus, is it 8 root 14 over, what have we got? 3 root 6 plus 8, 3 root 6 minus 8. Isn't that a squared minus b squared? What's 3 root 6 squared? It's 9 times 6. Careful. Minus what squared? Minus 8 squared or minus 64? Be careful. Because it's 3 squared times root 6 squared. So it's 9 times 6 minus 64. All right, square root of 84. 4 goes into it 21 times. That's it. Doesn't it? So it's 6 root 6 minus 16 minus, now square root of 84, just over here, is the square root of 4 times the square root of 21. See, 21's okay, it doesn't have any square numbers that go into 21, only 3 and 7 go into 21. So that's 2 root 21, all right? So minus 3 times 2 root 21 is 6 root 21 plus 8 root 14. You can't simplify. 14 is 7 times 2. None of them are squared numbers. Over 54 minus 64. Negative 10. Do we want a negative on the denominator? No. So the first one will be negative. The second one's positive. The third one's, sorry, negative, positive, positive, negative. Don't divide by, oh, wait, stop. You can still simplify. Can't you divide everything by 2 as well? So what we're going to do is divide everything by negative 2. Do you see what I'm doing? I'm going to divide the numerator and the denominator by negative 2. Divide by negative 2. So on the denominator, I'm going to have 5. So divide by negative 2, negative 3 root 6. Divide by negative 2 plus 8. Divide by negative 2 plus 3 root 21. And divide by negative 2 minus 4 root 14. You could have done it in 2 steps. You could have fixed your negatives first and then halved everything. Okay? Did anyone try rationalising each one separately and then... That's the other way to go, but, you know, should get the same answer. Right.